Something invisible is pulling our galaxy toward a hidden zone scientists call the zone of avoidance. We move through space at 455 miles per second, dragged by a force we cannot see or understand. Somewhere in the void between galaxies, radio signals scream across billions of years. Black holes that should not exist yet swallow stars. And 95% of everything around you is made of substances science cannot identify or explain. You are about to discover mysteries so disturbing that astronomers struggle to sleep after studying them. If you find this fascinating, hit that subscribe button. The journey into cosmic terror begins now. Scientists measured the rotation speed of stars at the edges of spiral galaxies and discovered something impossible. These outer stars move at the same velocity as stars near the center. According to every law of physics we understand, the outer stars should be moving slower, like planets farther from our star. They should drift away into empty space. Instead, they grip tight to their galaxies, as if something invisible holds them in place. This is confirmed by thousands of observations. Something we cannot see is keeping the universe from flying apart. Astronomers call this phantom substance dark matter. It does not absorb light. It does not reflect light. It does not emit any radiation we can detect. Yet dark matter makes up roughly 27% of everything that exists. Regular matter, everything you can touch and see, makes up only 5% of reality. You are a tiny fraction of a universe mostly built from the invisible. Think of the cosmos as a spider web. The galaxies are dewdrops caught in silk threads we cannot perceive. Without this hidden web, every galaxy would unravel. Every star would drift alone into darkness. Scientists have searched for dark matter particles for decades. They have built detectors deep underground to shield them from interference. They have looked for theoretical particles called WIMPs and axions. The experiments come back empty. Whatever holds the universe together refuses to reveal itself. Some researchers propose that our understanding of gravity is wrong. Maybe the laws change at cosmic scales. But this theory creates more problems than it solves. The evidence points to matter we cannot see. Dark matter was there when the first galaxies formed. Its gravity pulled regular matter together into the structures we observe today. Without it, you would not exist. Stars would never have clustered. Planets would never have formed. Life would never have begun. You are living inside a cosmic skeleton you will never see. Your body moves through dark matter every second. Millions of dark matter particles could be passing through your hand right now. You feel nothing. Science detects nothing. The invisible architecture that prevents total chaos remains a complete mystery. Astronomers estimate there are 5 times more dark matter than regular matter in the universe. Imagine walking through a crowded room where only one person in 6 is visible. The others push past you, their presence felt only by the movement of air and the sounds of footsteps. That is our reality on a cosmic scale. The most disturbing part? Dark matter might not be one substance. It could be multiple unknown particles, forces, or entities we lack the tools to comprehend. Every telescope aimed at the sky reveals more questions. Every calculation confirms we understand less than we thought. And this is only the beginning of what we do not know. What scientists discovered next makes dark matter look simple in comparison. The universe is accelerating toward its death. In the late 1990s, astronomers studying distant supernovas made a discovery that shattered cosmology. They expected the expansion of space to be slowing down, pulled back by gravity. Instead, they found the opposite. The universe expands faster every moment. Something pushes galaxies apart with increasing strength. This is confirmed by multiple independent observations. The force driving this acceleration is called dark energy. Dark energy makes up roughly 70% of all existence. It is the dominant force in reality. Yet scientists have no idea what it is. Every theory fails to explain its properties. Its very existence contradicts our understanding of physics. Imagine you throw a ball into the air. Gravity should slow it down until it falls back. Now imagine the ball accelerates upward instead, moving faster the higher it climbs. This violates everything you know about forces. Yet this is exactly what space itself does. Dark energy has negative pressure. It acts opposite to gravity, pushing instead of pulling. The more space expands, the more dark energy appears. It is not diluted by expansion. It grows stronger. Einstein predicted something like dark energy with his cosmological constant. He called it his biggest blunder and removed it from his equations. Decades later, observations proved he was right the first time. The universe will not collapse back on itself. There will be no big crunch. Instead, dark energy ensures a cold, lonely death. Billions of years from now, galaxies beyond our local group will accelerate away so fast that their light will never reach us. The night sky will go dark. Future civilizations will see only their own galaxy surrounded by nothing. This is called the Big Freeze. But there is something worse. Some models suggest dark energy might strengthen over time. If this happens, the acceleration could become so extreme that it tears apart galaxies, then solar systems, then planets, then molecules, then atoms. This scenario is called the Big Rip. In this nightmare, everything that exists would be shredded down to individual particles scattered across infinite space. The universe would not die quietly. It would be ripped to pieces. Scientists do not know which fate awaits us. Dark energy could remain constant. It could grow stronger. It could even reverse itself. Every measurement brings more confusion instead of answers. Some researchers propose that dark energy is a property of space itself. Others suggest it is a new field that permeates reality. A few theorists wonder if our equations of gravity are wrong at the largest scales. None of these ideas solve the problem. We are living in a universe controlled by a force we cannot identify, cannot predict, and cannot stop. It has been accelerating space for billions of years. You are already moving faster through the cosmos than you were when you started reading this. The expansion will continue. The acceleration will increase, and we have no power to change it. But if the universe is mostly invisible forces tearing reality apart, where did the matter we can see come from? Half of creation vanished. When the Big Bang occurred, the laws of physics should have created equal amounts of matter and antimatter. These twin substances are identical, except for one difference. When they touch, they annihilate each other in a burst of pure energy. The early universe should have been filled with both types in perfect balance. They should have destroyed each other completely. Nothing should remain. No stars, no galaxies, no planets, no you. Yet here we stand. This is confirmed. The universe is made almost entirely of matter. Antimatter has nearly disappeared. Scientists have no idea where it went or why the balance broke. Think of it like this. Imagine you walk into a room where 1,000 people in red shirts and 1,000 people in blue shirts are fighting. The rules say that when red touches blue, both vanish. You leave and return an hour later. Only the red shirts remain. 1,000 people in blue have disappeared. What happened? This is not a small problem. This is the foundation of existence. Something violated the symmetry that should have erased everything. Experiments at particle accelerators recreate the conditions of the early universe. They smash particles together and watch what emerges. Matter and antimatter appear in equal amounts. The symmetry holds perfectly in every test. Yet, clearly, in the first moments after the Big Bang, something broke this balance. The discrepancy is tiny. For every billion particles of antimatter, there were 1,000,000,001 particles of matter. That single extra particle of matter out of every billion became everything we observe. That 1 in a billion advantage created stars, planets, and life itself. Scientists call this baryon asymmetry. It is one of the deepest unsolved mysteries in physics. Some theories suggest there are subtle differences in how matter and antimatter decay. These differences might have given matter a slight advantage in the early universe. Experiments have detected small asymmetries in certain particle behaviors. but the measured differences are far too small to explain the overwhelming dominance of matter. Other researchers propose that antimatter was not destroyed. Instead, it exists in separate regions of space, far beyond what we can observe. Entire galaxies of antimatter might exist billions of light-years away. We would never know because antimatter behaves exactly like matter until the two meet. If this is true, there should be boundaries where matter and antimatter regions collide. These collision zones would produce massive amounts of gamma radiation. Astronomers have searched for such signals. They have found nothing. A darker possibility exists. The laws of physics might have been different in the first fraction of a second after the Big Bang. During that brief moment, symmetry broke. Matter gained dominance. Then the laws locked into the forms we observe today. If physics was different once, it could change again. You exist because of an imbalance that should not have happened. The fact that you can think, breathe, and wonder about this mystery means the universe broke its own rules. And if reality broke its rules once, what prevents it from breaking them again? Something stranger still is screaming at us from across the void. In 2007, astronomers found something screaming. A burst of radio energy hit Earth, lasting less than 5 milliseconds. In that fraction of a second, it released more energy than our star produces in several days. The signal came from billions of light-years away. Then it vanished. This is confirmed by hundreds of detections. Scientists call them fast radio bursts. Most appear once and never repeat. A few burst again in mysterious patterns. Nobody knows what creates them. These are not gentle signals. They are cosmic violence compressed into milliseconds. The energy output is staggering. Whatever produces fast radio bursts must involve extreme physics. Think of it like someone screaming so loud that you hear them from another continent. The force required would tear apart their throat. Fast radio bursts are similar. They require conditions so extreme they should destroy whatever creates them. Some fast radio bursts come from magnetars, neutron stars with magnetic fields trillions of times stronger than Earth's. These dead stars spin at incredible speeds. Their magnetic fields twist and snap like rubber bands stretched too far. When they break, they release bursts of energy that cross the universe. But magnetars do not explain all fast radio bursts. The signals show too much variety. Some repeat on schedules, others appear completely random. Some come from regions with no magnetars. Some are far too powerful for any known magnetar. One particular burst, designated FRB 2120, repeats every 16 days. It sends multiple bursts over 4 days, then goes silent for 12 days. The pattern repeats with eerie precision. What cosmic clock controls this? What mechanism can be so reliable yet so violent? Another burst came from inside our own galaxy in 2020. It allowed scientists to study a fast radio burst up close for the first time. The source was indeed a magnetar, but the burst was much weaker than the ones from distant galaxies. If the nearby burst represents typical magnetar behavior, something far more powerful must create the distant ones. Some researchers propose that fast radio bursts come from black holes shredding neutron stars. Others suggest colliding neutron stars. A few think the bursts come from alien megastructures beaming energy across space. None of these theories explain all the observations. The most disturbing possibility is that fast radio bursts are common. They happen constantly across the universe. Thousands might occur every day. We only detect the ones aimed directly at Earth. Imagine the cosmos filled with these cosmic screams, most of them pointed away from us into the void. What if the universe is not silent? What if it is screaming all the time and we are just beginning to hear it? New radio telescopes are being built to capture more bursts. Each detection brings new questions. Some bursts show polarization, suggesting they pass through magnetic fields. Others show no polarization. Some seem to come from dense galaxy clusters. Others originate in empty regions of space. Fast radio bursts might be the key to understanding magnetars, black holes, and the behavior of matter under extreme conditions. Or they might be something else entirely. Among these cosmic screams, one signal stands out above all others. On August 15th, 1977, Earth received a message. The Big Ear radio telescope in Ohio detected a narrowband radio signal lasting 72 seconds. The signal was strong, focused, and came from the direction of the constellation Sagittarius. Astronomer Jerry Eman reviewed the data days later. He circled the intensity, reading on the printout, and wrote one word in red ink. Wow, this is confirmed. The signal happened. Its properties matched exactly what scientists expected from an alien transmission. The signal appeared at 1420 MHz, the natural frequency of hydrogen. This is the most common element in the universe. Any intelligent species would know this frequency. It is the universal channel for communication. The signal was narrowband, focused on a specific frequency rather than spread across many. Natural cosmic phenomena produce broadband signals. They emit energy across wide ranges. The WOW signal did the opposite. It behaved like an intentional broadcast. Think of it like hearing a voice on a specific radio station instead of static across all frequencies. The specificity suggests purpose. The Big Ear telescope used 2 receivers. If the signal was real, both should have detected it as Earth rotated. Only one receiver captured it. This creates doubt but does not disprove anything. The signal might have been a brief burst that ended before the second receiver pointed in its direction. Scientists have searched that region of sky 50 times since 1977. They have never found the signal again. No repeat, no pattern, just silence. Multiple theories attempt to explain the WOW signal. Some researchers proposed it came from passing comets, but this was debunked. Comets do not emit strongly at hydrogen frequencies. Others suggested satellites or Earth-based interference, but the signal's properties do not match. In 2024, new research proposed a natural explanation. A magnetar might have fired a burst of radiation through a cold hydrogen cloud. This could have amplified the cloud's natural hydrogen emission into a powerful maser, creating a laser-like beam of radio energy. The WOW signal could have been a rare astrophysical event. This is a theory. It fits some observations, but it requires an incredibly specific alignment. The magnetar would need to fire at the exact moment when Earth pointed its telescope at the exact location where a hydrogen cloud floated. The odds are extraordinarily low. Astronomer Avi Loeb recently suggested another possibility. An interstellar object called 3I/Atlas is passing through our solar system. Its trajectory aligns suspiciously well with the WOW signal's origin point. Could this object have transmitted the signal in 1977 when it was 600 times Earth's distance from our star? Nobody knows. The signal remains unexplained. If the WOW signal was a message, it raises terrifying questions. Why did it happen only once? Was it a greeting? A warning? An accidental leak of energy from technology we cannot comprehend? If someone tried to contact us, why have they been silent for nearly 50 years? Perhaps they are waiting for a response. Perhaps they moved on. Perhaps they vanished. Or perhaps they are watching while we search the skies for signals. One star refuses to follow any rules we understand. 1470 light-years away, a star is doing something no star should do. Tabby's star dims by up to 22%. Normal planets block less than 1% of their star's light when they pass in front. 22% means something enormous is orbiting that star, something far larger than any planet should be. This is confirmed by years of observations. The dimming is real. The pattern is irregular. It makes no sense. When a planet transits its star, the dimming follows a predictable curve. Light decreases smoothly as the planet moves across the disk, then increases smoothly as it exits. The dimming happens at regular intervals matching the planet's orbit. Tabby's star does none of this. Its dimming patterns are chaotic. Sometimes the star loses 15% of its light. Sometimes 5%. Sometimes it dims for days. Sometimes for weeks. The events show no regular timing. Think of someone flicking a light switch on and off randomly. You cannot predict when darkness comes or how long it lasts. This is how Tabby's star behaves. Scientists propose that a swarm of comets orbits the star. Comets leave trails of dust and debris. As these clouds pass between us and the star, they block light. But comet swarms should produce infrared radiation as dust absorbs and re-emits starlight. Astronomers looked for this infrared signature. They found nothing. Other theories suggest a shattered planet orbits Tabby's star. A collision destroyed the planet billions of years ago. The debris field still orbits, causing irregular dimming. This could work, but such a debris field should glow with infrared radiation from friction and impacts. Again, observations show no infrared excess. A more disturbing idea emerged. Perhaps the dimming comes from an alien megastructure. An advanced civilization might build massive solar collectors around their star to harvest energy. These structures, called Dyson swarms, would block starlight as they orbit. They would create irregular dimming patterns. Scientists searched Tabby's star for signs of technology. They looked for narrow radio signals indicating artificial transmissions. They found nothing. No signals. No evidence of intelligence. Just unexplained dimming. Recent research suggests the dimming might come from dust clouds with specific properties. The dust must be fine and distributed in a particular way. This could block visible light while allowing infrared to pass through, explaining why infrared observations show nothing unusual. But this theory creates new problems. Where does the dust come from? Why is it distributed so irregularly? What mechanism produces clouds large enough to block 22% of starlight? Data shows Tabby's star has been gradually dimming over the past century. In addition to the dramatic, irregular events, the star's overall brightness has decreased by approximately 15%. This long-term trend suggests something is changing. Something is growing around that star or consuming its light. Astronomers continue monitoring Tabby's star. Every time they think they understand it, the star produces a new dimming event that does not fit previous patterns. We are watching something happen 1470 light-years away. We see light from 1470 years ago. Whatever is causing this dimming has had 14.5 centuries to evolve or grow. What is it now? What will it be when its current light reaches us? Something far closer is dragging us through space against our will. Our galaxy is falling towards something we cannot see. The Milky Way moves through space at 455 miles per second toward a region astronomers call the zone of avoidance. We are not drifting, we are being pulled. Thousands of other galaxies rush toward the same point. Something massive hides behind thick clouds of gas and dust in our own galaxy, blocking our view. This is confirmed. The motion is measurable. The destination is hidden. Scientists discovered this gravitational anomaly in the 1970s. They measured the motion of galaxies and found that every galaxy in our cosmic neighborhood moves in the same direction. Not because of the universe's expansion. This is different. This is attraction. Something enormous pulls us with such force that it overcomes the normal motions of galaxies. The hidden region lies about 200 million light-years away. Between us and the great attractor sits the disk of the Milky Way. Our view is blocked by stars, gas clouds, and cosmic dust. It is like trying to see through a thick forest. We know something large is behind the trees but cannot make out its shape. Think of it as swimming in a river. You feel the current pulling you downstream. You know there is something ahead causing the flow, but fog surrounds you. You cannot see what waits in the direction you are being dragged. Using X-ray telescopes and radio observations, astronomers have pieced together fragments of information. The Great Attractor appears to be a massive concentration of galaxies, but the total mass of visible matter is not enough to explain the strength of the gravitational pull. Something adds extra mass, something we cannot detect. Could this be dark matter? Probably. But the concentration would need to be enormous. The regular matter alone contains the mass of tens of thousands of galaxies. The dark matter would need to be many times greater. Recent discoveries revealed that the Great Attractor is not the ultimate source of our motion. It is part of something larger. Our local supercluster, containing the Milky Way and tens of thousands of other galaxies, belongs to an even bigger structure called Laniakea. This massive cosmic web spans 520 million light-years. We are one small current in a vast ocean of galaxies flowing toward the center of Laniakea. But even Laniakea is moving. The entire supercluster is being pulled toward an even more distant region called the Shapley concentration. This lies 650 million light-years away, beyond the Great Attractor. It contains tens of thousands of galaxies. We exist in a hierarchy of cosmic flows. Our solar system orbits within the Milky Way. The Milky Way falls toward the Great Attractor. The Great Attractor flows toward the Shapley concentration. Everything moves within structures so large they defy comprehension. You are traveling through space right now, faster than you can imagine. You orbit inside a galaxy, rushing toward something hidden behind dust. That galaxy flows within a supercluster, pulled by an even greater mass. The speed compounds. The journey never stops. Where does it end? What happens when we finally reach these massive attractors? Will the Milky Way merge with other galaxies? Will we be torn apart by tidal forces? The answer waits millions of years in the future. We cannot escape the fall. While gravity drags entire superclusters together, other regions of space contain almost nothing at all. 330 million light-years of nearly empty space should not exist. In 1981, astronomer Robert Kirshner discovered a spherical region containing almost no galaxies. He searched the void expecting to find 2,000 galaxies based on the average density of the universe. He found 60. The rest simply are not there. This is confirmed. The void is real. It is one of the largest known structures in existence. If the Milky Way sat in the center of the Boötes void, we would not have discovered other galaxies until the 1960s. Early telescopes would have shown nothing beyond our own stars. We would have believed we were alone in an empty cosmos for decades longer. Think of finding a massive hollow bubble in solid rock. The rock surrounds the bubble on all sides, yet the inside contains almost nothing. The Boötes void is similar. Galaxies surround it like walls, but the interior remains nearly vacant. Scientists have no confirmed explanation for how such a large void formed. The universe is only 13.8 billion years old. In that time, gravity should not have been able to clear out a region this enormous. There has not been enough time for galaxies to be pushed or pulled that far. Some researchers propose that the void formed through the merger of smaller voids. Like soap bubbles joining to create one large bubble, smaller empty regions might have coalesced over billions of years. The few galaxies inside the void might be remnants trapped at the boundaries where smaller voids merged. Others suggest the void is natural. When the universe was young, matter was not distributed perfectly evenly. Some regions started with slightly more matter. Gravity pulled this matter together, forming galaxies. Other regions started with slightly less matter. They became voids, as their few particles were pulled away by the gravity of denser regions nearby. But the Boötes void is too large for this explanation. The statistical probability of a void this size forming naturally is extremely low. Something else might be happening. A controversial theory proposes the void could be artificial. An advanced civilization could have enclosed every star in their galaxy within Dyson spheres to harvest energy. As they expanded, they enclosed more stars. Over hundreds of millions of years, they might have dimmed thousands of galaxies. From our perspective, the region would appear empty because we detect no light. This theory remains pure speculation. There is no evidence of any civilization. The void shows no unusual patterns suggesting intelligence. It is simply empty. The 60 galaxies found inside the void behave strangely. They are brighter on average than galaxies found elsewhere. Why would galaxies in a void be brighter? The mystery deepens. Recent observations show that voids are everywhere. They make up roughly 80% of the universe's volume. Between the cosmic web of galaxies lie vast stretches of nearly nothing. The Boötes void is simply one of the largest. You live in a universe that is mostly empty. Galaxies cluster along filaments and walls surrounding enormous bubbles of void. These structures span hundreds of millions of light years. The architecture of reality is foam, and that foam contains structures that should not fit inside our universe. 80% of the universe is holes. Between the glowing threads of galaxies lie vast, empty regions where almost nothing exists. These cosmic voids contain fewer than 1/10 the normal density of matter. They span hundreds of millions of light years. Together, they occupy most of space. This is confirmed by galaxy surveys mapping the large-scale structure of the cosmos. The universe is not smooth. It resembles a sponge or foam, with matter concentrated along thin walls and filaments surrounding empty bubbles. The local void sits near our own galaxy. It stretches 60 million light-years across. We live on its edge. Our galaxy moves away from the void at approximately 260 miles per second. The void repels us. Think of voids as anti-gravity wells. Dense regions pull matter toward them. Voids push matter away. They are not truly empty, but they contain so little matter that their gravity is negligible. Meanwhile, the dense regions surrounding them pull more strongly, draining whatever matter exists inside the void. Scientists understand how small voids form. When the universe was young, density fluctuations created slightly empty regions. As denser areas pulled matter toward themselves, they emptied the voids further. This is called gravitational evacuation. But the largest voids are too big. There has not been enough time since the Big Bang for gravity to create such enormous empty regions. The expansion of space works against void formation. As space expands, it should work to smooth out density differences. Instead, we observe voids growing larger. The KBC void might contain our entire local galaxy cluster. Named after the scientists who discovered it, this potential void could be 1 to 2 billion light-years across. If confirmed, we exist inside a cosmic bubble of relative emptiness. Most of the universe surrounding us for 1 billion light-years contains fewer galaxies than average. This has disturbing implications. Scientists use observations of distant supernovas to measure the expansion rate of the universe. But if we sit inside a void, our measurements might be biased. The expansion might appear faster from inside a low-density region than it actually is throughout the rest of space. Our understanding of dark energy could be wrong. The accelerating expansion we observe might be partly an artifact of our location inside a void. We might be measuring local effects and assuming they apply everywhere. Another mysterious void is the Eridanus supervoid. This region might explain the cold spot in the cosmic microwave background, an anomaly we will explore shortly. The supervoid sits roughly 3 billion light-years away and measures 500 million to 1 billion light-years across. Light from the early universe passed through this void. As it crossed the nearly empty region, it lost energy through a process called the integrated Sachs-Wolf effect. This energy loss makes that portion of the cosmic microwave background appear colder than surrounding areas. Voids are not passive empty spaces. They actively shape the evolution of the universe. They influence how galaxies form and cluster. They affect measurements of cosmic expansion. They create observable effects on the oldest light in existence. You might imagine space as mostly full of stars and galaxies with occasional gaps. The truth is reversed. Space is mostly empty with occasional clusters of matter. We live in the foam of reality, clinging to one of the thin walls between vast bubbles of nothing. One of those bubbles left a permanent scar on the universe itself. There is 1 billion light-year hole in the afterglow of creation. When astronomers mapped the cosmic microwave background, the faint radiation left over from the Big Bang, they found an anomaly. a region of space appears 70 microkelvins colder than the surrounding area. In some places, the temperature drops by 140 microkelvins. The cold region spans roughly 5 degrees of sky. This is confirmed by multiple satellites, including WMAP and Planck. The cold spot is real. It should not exist. The cosmic microwave background shows temperature variations across the sky. These variations are echoes of density fluctuations in the early universe. Hot spots and cold spots are normal, but they follow statistical rules. They have predictable sizes and temperature differences. The cold spot breaks these rules. It is far too large and far too cold. Based on our understanding of the early universe, the probability of such a large, cold region appearing by random chance is less than 1%. Some calculations suggest less than 0.2%. Think of shuffling a deck of cards and finding all 52 cards perfectly ordered by suit and rank. It is possible, but so unlikely that you would immediately suspect something else happened. The cold spot is similar. Its properties are so unusual that scientists search for explanations beyond random chance. One theory proposes that the Eridanus supervoid causes the cold spot. Light from the cosmic microwave background traveled through this enormous void on its way to Earth. As photons crossed the nearly empty region, they lost energy through the integrated Sachs-Wolf effect. This energy loss makes the light appear colder. Recent observations have confirmed a large underdensity of matter in the direction of the cold spot. Dark matter maps show the same underdensity. The supervoid exists. But calculations suggest it can only explain about 30% of the cold spot's temperature drop. Something else must account for the remaining 70%. Another hypothesis proposes that local galaxies near Earth create a foreground effect. Radiation from nearby galaxy groups might interact with the cosmic microwave background, creating an apparent cold region. Some models show this could produce a temperature pattern matching the cold spot, but this theory remains controversial. The most disturbing possibility is that the cold spot is evidence of another universe. Before cosmic inflation separated our universe from others, quantum entanglement might have connected multiple universes. A collision or interaction between our universe and another could have left a scar. That scar would appear as an anomaly in the cosmic microwave background. This theory is controversial and difficult to test. How do you prove another universe exists? How do you measure something beyond the boundaries of all observable space? Some researchers argue the cold spot is a statistical fluke. Given enough sky to survey, eventually a rare feature should appear. We simply got unlucky and observed an unlikely but possible random fluctuation. Others suggest the physics of the early universe was more complex than we understand. Unknown processes during the first moments after the Big Bang might have created this feature. The cold spot has been studied for 20 years. Each new observation brings more questions. The answer matters because it tells us whether our universe is truly random, whether it interacted with others, or whether our models of early cosmic history are incomplete. A cold scar in the afterglow of creation might be evidence that reality is larger and stranger than anything we have imagined. While we wonder about collisions between universes, countless frozen worlds drift alone through the darkness. Trillions of planets drift through space untethered to any star. These rogue planets were ejected from their solar systems during formation or torn away by gravitational interactions. They travel alone through interstellar space, frozen and dark, receiving no warmth from any star. They are invisible ghosts wandering the void between galaxies. This is confirmed by gravitational microlensing observations. When a rogue planet passes between Earth and a distant star, its gravity bends the starlight. For a brief moment, the star brightens. From these rare events, astronomers estimate the number of rogue planets. The estimates are staggering. There might be more rogue planets than stars in the Milky Way. Billions or trillions of worlds drift alone in darkness. Some are gas giants larger than Jupiter. Others are rocky planets like Earth. They orbit nothing. They receive no light. Their surfaces are frozen wastelands, colder than anything we can imagine. Think of a city at night with the power cut. Every building is dark, every street is empty. Now imagine that darkness lasting billions of years without any hope of sunrise. That is the existence of a rogue planet. Some rogue planets might have moons. These moons would orbit the planet as they drift through space together. Tidal forces between planet and moon could generate heat through friction. Deep beneath frozen surfaces, subsurface oceans might exist. These oceans would be completely isolated from the rest of the universe, warmed only by the gravitational dance between planet and moon. Could life exist in such places? On Earth, life thrives near hydrothermal vents deep in oceans where no sunlight reaches. Energy from chemical reactions and heat from Earth's core supports entire ecosystems. A rogue planet with a large moon and a warm core might host similar life, but any civilization evolving on a rogue planet would face an incomprehensible existence. They would know nothing but darkness. They might never discover other planets, stars, or galaxies. If they developed telescopes, they would see only empty space. They would believe the universe contained nothing but their own frozen world. Recent studies suggest some rogue planets might be larger than Jupiter and generate their own heat from gravitational contraction. These failed stars, not quite massive enough to ignite fusion, could glow faintly in infrared. They would create tiny bubbles of warmth in the cosmic cold. Scientists estimate that a rogue planet passes within a few light years of Earth, roughly every 1,000 years. They are common, but invisible. We only detect them through lucky alignments, when they pass in front of distant stars. The nearest rogue planet could be closer than the nearest star. It might drift through the outer reaches of our solar system undetected. Its gravity would be too weak to perturb the orbits of known planets. Its surface would be too cold to emit detectable radiation. It would be a dark intruder passing silently through our cosmic neighborhood. Some rogue planets were ejected from their solar systems at such high speeds that they will eventually leave their galaxies entirely. They will wander intergalactic space, the most isolated objects in existence, forever separated from everything. The universe is darker than we thought. Between every visible star might drift dozens of invisible worlds. They form a hidden population, a shadow cosmos we are only beginning to discover. But if countless planets exist, why have we never heard from anyone living on them? Where is everybody? Our galaxy contains approximately 200 billion stars. Many of these stars host planets. Billions of those planets orbit in habitable zones where liquid water could exist. Even if only a tiny fraction develop life, and only a tiny fraction of those develop intelligence, the numbers suggest millions of advanced civilizations should exist in the Milky Way alone. This is a statistical argument confirmed by decades of exoplanet discoveries. The ingredients for life are common. The universe has existed for 13.8 billion years. There has been plenty of time for civilizations to arise. Yet we have detected no signals, no transmissions, no probes, no megastructures, no evidence of anyone else. The silence is absolute. Physicist Enrico Fermi asked the question that haunts astronomy. If aliens exist, where are they? Why have we seen no sign of them? This is called the Fermi paradox. Think of standing in a massive city and hearing no sounds, no voices, no traffic, no music, just silence. You know millions of people should be nearby, but you hear nothing. Where did everyone go? Several disturbing explanations exist. The first is that life is rare. Perhaps Earth is an extraordinary fluke. Perhaps the chain of events leading from chemistry to intelligence is so improbable that it happens only once per galaxy or less. We might be alone. The second explanation is that civilizations destroy themselves. Perhaps every intelligent species eventually develops weapons or technologies capable of causing extinction. Perhaps the window between discovering radio waves and annihilating yourself is very short. We might be surrounded by the ruins of dead civilizations. The third possibility is that advanced civilizations exist but remain silent. They might have reasons to avoid contact. Perhaps they observe us, but choose not to interfere. Perhaps they know something about the universe that makes broadcasting dangerous. The dark forest theory proposes that the universe is filled with predatory civilizations. Any species that reveals its location attracts attention from more powerful entities who view them as threats or resources. Survival requires silence. Broadcasting your existence is suicide. Another hypothesis suggests we are simply not interesting enough. Advanced civilizations might operate on timescales and energy levels so beyond our comprehension that we are invisible to them. They exist but do not notice us, the same way you do not notice individual bacteria. The Great Filter theory is perhaps the most disturbing. It proposes that there is a barrier preventing life from reaching advanced stages. Either the jump from chemistry to life is nearly impossible, or the jump from simple life to intelligence is nearly impossible, or something else waits ahead of us that destroys civilizations before they spread beyond their home planets. If the Great Filter is behind us, we are lucky survivors. If it lies ahead, we are doomed. Recent studies suggest that technological civilizations might only last a few thousand years before collapsing. Our own civilization has had radio technology for only about 130 years. Perhaps civilizations are like candles flickering briefly against an infinite darkness. They arise, shine for a moment, then extinguish. We have searched for signals for over 60 years. We have found nothing conclusive. The WOW signal remains our closest brush with possible alien contact, and it never repeated. You exist on a planet filled with life, orbiting a star in a galaxy containing billions of stars. Logic says you should have neighbors. Observation says you do not. The silence suggests something is very wrong. Either we are alone, or something prevents civilizations from surviving long enough to meet each other. Both possibilities are terrifying. While we search in vain for signals, we have found something else that should not exist. Black holes born in an impossible era. At the center of every large galaxy lurks a monster. Supermassive black holes contain millions to billions of times the mass of our star. They warp space and time around themselves. Nothing that crosses their event horizons can escape, not even light. Their gravity tears apart stars that drift too close. This is confirmed by observations of stellar orbits near galactic centers and direct imaging of black hole shadows. Supermassive black holes are real, but we have no idea how they formed. The problem is time. When astronomers look at the most distant galaxies, they see light from when the universe was less than 1 billion years old. Those ancient galaxies already contain fully formed supermassive black holes. The monsters were there from the beginning. Think of finding a fully grown tree 1 year after a forest fire. The seed should not have had time to germinate, grow, and mature. Yet there it stands, impossible but real. Supermassive black holes are similar. They appeared too early. Black holes form when massive stars die. When a star 20 times more massive than ours exhausts its fuel, its core collapses. If the core is heavy enough, nothing can stop the collapse. It becomes a stellar black hole containing perhaps 10 to 100 times our star's mass. These stellar black holes could grow by consuming gas and dust from their surroundings. But growth is slow. Black holes cannot eat faster than a certain rate. Material falling in creates friction and heats up, producing radiation that pushes other material away. This limits how quickly a black hole can gain mass. Starting from a stellar black hole of 100 masses and growing at the maximum rate, it would take billions of years to reach millions of masses. But the universe was not billions of years old when the first supermassive black holes appeared. They had perhaps 800 million years. The math does not work. Some researchers propose that supermassive black holes did not start as stellar black holes. Perhaps they formed differently. In the early universe, massive clouds of gas might have collapsed directly into large black holes without ever becoming stars. These seed black holes could have been thousands of times more massive than stellar black holes, giving them a head start. But direct collapse requires specific conditions. The gas must be extremely pure, mostly hydrogen and helium with almost no heavier elements. Heavy elements allow gas to cool and form stars. The conditions for direct collapse were rare even in the early universe. Another theory suggests primordial black holes formed during the first fraction of a second after the Big Bang. Density fluctuations might have created regions where matter was compressed enough to form black holes immediately. These primordial black holes could have served as seeds for supermassive black holes. Recent observations show some black holes grew even faster than the maximum theoretical rate. They appear to violate the laws governing black hole growth. Either our understanding of how matter falls into black holes is wrong, or something else is happening. We also do not understand how black holes and galaxies are connected. The mass of a supermassive black hole closely correlates with the mass of the galactic bulge surrounding it. Somehow, the black hole and galaxy grow together. They influence each other across vast distances. The mechanism remains a mystery. You orbit a star that orbits a galaxy that orbits a supermassive black hole containing 4 million times the mass of that star. The black hole is called Sagittarius A star. It sits 26,000 light-years away. If our galaxy exists because the black hole pulled matter together, and if the black hole formed too early to exist, what does that say about the foundations of reality? While these monsters hide at galaxy centers, mysterious perfect circles have appeared in the cosmos. Perfect circles, 1 million light-years across, hover in deep space. In 2019, astronomers discovered enormous ring-shaped structures emitting only radio waves. These odd radio circles are invisible to optical telescopes. They appear only in radio observations as perfect or near-perfect circles surrounding galaxies. This is confirmed by multiple observations from different radio telescopes. The circles are real. Nobody knows what creates them. Each circle spans roughly 1 million light-years in diameter. They are bigger than most galaxies. Their edges are sharp and well-defined. The symmetry is unsettling. Natural phenomena rarely produce such perfect shapes at cosmic scales. Think of finding a perfectly drawn circle etched into stone the size of a continent. No tool you know could create something so large and so precise. The scale suggests forces beyond comprehension. Odd radio circles are similar. The physics required to create such structures remains unknown. Only a handful have been discovered. This makes sense because they emit only in radio wavelengths. We only recently built radio telescopes sensitive enough to detect them. They might be common, but invisible to older instruments. The circles appear to be associated with galaxies. At the center of each circle sits a galaxy. This cannot be coincidence. Whatever creates odd radio circles originates from or near these galaxies. Scientists have proposed several explanations. The leading theory suggests the circles are shock waves from massive explosions. Perhaps two supermassive black holes merged, releasing gravitational waves and an explosion of energy. The shock wave from such an event could expand outward, pushing gas and dust into a spherical shell. We might see this shell from an angle that makes it appear circular. Another hypothesis proposes that odd radio circles are created by jets of material shot from supermassive black holes. These jets might precess like wobbling tops, spraying material in different directions. Over time, the combined effect could create a circular structure. A third idea suggests starburst galaxies create the circles. When many stars form simultaneously and then explode as supernovas, the combined energy could blow material outward in all directions. Millions of years later, this material might appear as a radio ring. But none of these theories explain all observations. The circles are too perfect. The scale is too large. The rarity is unexplained. Some odd radio circles show multiple concentric rings like ripples spreading across a pond. What could create multiple expanding shells of radio-emitting material? The mechanism remains unclear. The circles expand slowly. By measuring their size and estimated expansion speed, astronomers calculate they are millions of years old. We are seeing ancient events. The explosions or processes that created these structures happened long ago. We observe only the aftermath. What happened to the galaxies at the centers? Did they survive the event that created the circle? Are they still there? Or have they been destroyed? Without optical observations showing the central galaxies in detail, we cannot know their current state. Odd radio circles might be common throughout the universe. We might have overlooked thousands because they require specific radio observations to detect. As new radio telescope arrays come online, more circles might appear. Each new circle discovered brings new questions. Why do some have multiple rings while others have one? Why are the circles so symmetrical? What determines their size? The cosmos is filled with invisible structures, revealed only when we look with new eyes. What else have we missed? While we puzzle over radio circles, the universe sends us vibrations from its most violent events. Space itself is shaking. In 2015, detectors measured ripples in the fabric of space-time. Two black holes 30 times more massive than our star had merged 1.3 billion light-years away. The collision released more energy than all stars in the observable universe combined for that brief moment. The energy did not travel as light. It traveled as distortions in space itself. This is confirmed. Gravitational waves are real. Einstein predicted them a century ago. We finally detected them. The detectors are called LIGO and Virgo. They use lasers to measure changes in the distance between mirrors, separated by several miles. When a gravitational wave passes, space stretches and compresses. The distance between mirrors changes by less than the width of a proton. These instruments can measure that. Think of dropping a stone in a pond. Ripples spread outward across the water's surface. Gravitational waves are similar, except they ripple through space-time itself. Every massive accelerating object creates them. But only the most violent cosmic events create waves strong enough to detect across billions of light-years. Since 2015, detectors have captured dozens of gravitational wave events. Most come from merging black holes. Some come from colliding neutron stars. Each detection reveals information about extreme physics, but mysteries remain. Some of the detected black hole mergers involve black holes more massive than should exist from stellar collapse. These intermediate mass black holes contain between 100 and 1,000 stellar masses. We do not know how they form. One detected merger involved a black hole and a neutron star. When they collided, the black hole might have torn the neutron star apart before swallowing it, or the neutron star might have been swallowed whole. The gravitational wave signal ended before we could tell. What happens to matter at the moment it crosses an event horizon remains unknown. Scientists expected to detect a background hum of gravitational waves from countless unresolved sources throughout the universe. Millions of black hole mergers occur constantly across cosmic history. Their waves should overlap, creating a background noise. So far, this background has not been clearly detected. Either there are fewer mergers than expected, or something absorbs or dampens the waves. Future space-based detectors will be sensitive to different frequencies. They will detect supermassive black hole mergers that ground-based detectors cannot sense. These mergers involve black holes millions of times more massive than our star. The waves from such events have wavelengths too long for current detectors. What will we find? Will supermassive black hole mergers behave as predicted? Or will they reveal new physics? Some theoretical models predict exotic sources of gravitational waves. Cosmic strings, theoretical defects in space-time left over from the early universe, could emit gravitational waves. Collisions between domain walls, another theoretical remnant of phase transitions in the infant cosmos, might create detectable signals. If detected, these signals would revolutionize physics. They would confirm phenomena never directly observed. They would open windows into the first moments after the Big Bang. Gravitational waves carry information that light cannot. Light interacts with matter and gets absorbed, scattered, or blocked. Gravitational waves pass through everything unimpeded. They arrive unchanged from their source. They are pristine messengers from the most violent events in cosmic history. We have only just learned to hear them. Each new detection brings surprises. The universe is more violent and more strange than models predicted. Among these discoveries, some signals come from our own galaxy's heart, massive lobes of radiation that should not exist. Two enormous lobes of gamma radiation extend 50,000 light-years from the center of the Milky Way. These structures, called the Fermi bubbles, were discovered in 2010. They had been hidden in plain sight, obscured by the bright gamma-ray emissions from our galaxy's disk. Only when astronomers subtracted known sources did the bubbles become visible. This is confirmed by observations from the Fermi Gamma-Ray Space Telescope. The bubbles are real, they are massive, and nobody knows what created them. The bubbles extend 25,000 light-years above and 25,000 light-years below the galactic plane. They form an hourglass shape with sharp, well-defined edges. The gamma rays indicate high-energy processes occurred at the galaxy's core. Think of finding blast marks extending from the center of a city in opposite directions. The marks suggest an explosion, but the city still stands. Something violent happened, but not violent enough to destroy everything. The Fermi bubbles are similar. They suggest our galaxy experienced a massive energetic event. The leading theory proposes that Sagittarius A star, the supermassive black hole at our galaxy's center, was more active in the past. Perhaps it consumed a large amount of matter several million years ago. The material falling into the black hole would have heated to billions of degrees, emitting intense radiation. Some of this energy might have been channeled into jets, shooting outward perpendicular to the galactic disk. These jets could have plowed through gas and dust, pushing it outward and creating the bubble shapes. The gamma rays we detect come from this shocked gas interacting with cosmic rays. But this theory has problems. The bubble's edges are too sharp. Jets typically create messier structures with diffuse boundaries. The Fermi bubbles look almost like they were cut with a knife. Another hypothesis suggests a starburst event created the bubbles. Perhaps millions of stars formed near the galactic center in a short time. When these stars exploded as supernovas, the combined energy drove a powerful wind outward. This wind could have excavated the bubbles. Recent discoveries have added complexity. X-ray observations revealed structures within the gamma-ray bubbles. These inner features might represent an earlier, smaller explosion. Perhaps the Fermi bubbles formed through multiple events separated by millions of years. Measurements suggest the bubbles are relatively young, perhaps only a few million years old. This is recent in galactic terms. Our galaxy is over 13 billion years old. The event that created the bubbles happened in the cosmic equivalent of yesterday. What does this mean for us? We orbit within the same galaxy that produced these structures. Could a similar event happen again? If Sagittarius A star suddenly became active and shot jets of radiation through the galactic plane, what would happen to solar systems in the path? The radiation would not reach us quickly. We sit 26,000 light-years from the galactic center, far from the jet's path. But the long-term effects on the galactic environment remain unclear. The Fermi bubbles prove our galaxy is not static. It experiences violent events. Energy equivalent to millions of supernovas was released from the core. That energy is still visible as glowing gamma rays. We live in the aftermath of galactic violence. The scars glow above and below us, and we only noticed them recently because we lacked the instruments to see gamma rays. What else have we missed because we cannot yet observe the right wavelengths? The universe is not random. When astronomers mapped the positions of millions of galaxies, they discovered something impossible to ignore. Galaxies are not scattered evenly through space. They form a pattern. Long filaments of galaxies connect like threads in a vast web. Where threads intersect, massive clusters form. Between the threads lie enormous voids. This is confirmed by every large-scale survey. The cosmic web is real. It extends across billions of light-years, and it looks designed. The largest known structure in the observable universe is the Hercules Corona Borealis Great Wall. This galactic filament spans 10 billion light years. Light takes 10 billion years to cross it. The structure is so large, it should not exist. According to cosmological principles, the universe should not contain structures larger than a few billion light years. Yet here it stands. Think of looking at a city from space at night. The lights form patterns. Roads connect neighborhoods. Highways link cities. The pattern emerges from billions of individual decisions. But from above it looks intentional. The cosmic web is similar, except the scale is incomprehensible. Computer simulations can recreate the cosmic web. Scientists input the known physics of gravity and dark matter. They simulate the evolution of the universe from the Big Bang forward. The simulations produce structures matching observations. Gravity alone, working over billions of years, creates the web. But why does it look so organized? Why does matter cluster along specific pathways? The answer lies in the early universe. Tiny quantum fluctuations during the first fraction of a second after the Big Bang created regions of slightly different density. These variations were incredibly small, less than 1 part in 100,000. Over billions of years, gravity amplified these variations. Denser regions pulled matter toward themselves. They grew denser still. Empty regions became emptier as their matter was pulled away. The process fed on itself. Dense areas formed the filaments and nodes of the web. Empty areas became voids. The cosmic web maps the distribution of dark matter. Regular matter follows dark matter's gravitational pull. Where dark matter concentrates, galaxies form. The web we observe is the skeleton of reality, the scaffold on which visible structures hang. Recent observations show that gas threads connect galaxies along web filaments. This intergalactic medium was predicted but difficult to detect. It glows faintly in X-rays and ultraviolet. The threads are real physical structures, not just gravitational pathways. Matter flows along the web. Galaxies do not sit still. They move along filaments toward the densest nodes. This creates cosmic rivers of galaxies flowing through space. We are part of one such river, moving with thousands of other galaxies toward the center of Laniakea. The cosmic web reveals that the universe has structure on the largest possible scales. Nothing bigger exists, because we can only observe a finite volume. But the web presumably continues beyond what we can see. It might extend infinitely in all directions, filling all of space with its pattern. You exist on a planet orbiting a star inside a galaxy flowing along a filament in a web that spans the cosmos. Your location in this structure is not random. Everything that happened in cosmic history led to your galaxy forming where it did. But there is something stranger about the web. When scientists examined its largest features, they found something that challenges everything we thought we understood. The universe appears to point at Earth. When scientists analyzed the cosmic microwave background, they found large-scale features that should be randomly oriented. These features represent temperature variations in the infant universe. They should have no preferred direction. They should be scattered randomly across the sky. Instead, they align with each other, and they align with the plane of our solar system. This is confirmed by multiple satellite observations. The alignment is real. It has been called the axis of evil because it suggests something fundamentally wrong with our understanding of cosmology. The axis of evil contradicts the Copernican principle, the idea that Earth occupies no special position in the universe. We should not be at the center of anything. The cosmos should look the same in all directions. Large-scale features should not preferentially align with our solar system's motion or orientation. Yet they do. Think of throwing dice and getting the same number 20 times in a row. It is possible, but so unlikely that you would suspect the dice are loaded. The axis of evil is similar. The probability of this alignment occurring by chance is extremely low. Some scientists argue this is a statistical fluke. Given enough features to measure, eventually some will align by accident. We notice the alignments and ignore the features that do not align. This is called selection bias. Others suggest the alignment is caused by systematic errors in data processing. Perhaps the way we remove foreground contamination from the cosmic microwave background creates artificial patterns. The alignment might be an artifact of our analysis methods rather than a real cosmic feature. But the alignment has survived 20 years of scrutiny. Multiple independent teams have analyzed the data. Different satellites have confirmed the pattern. If it is an error, it is a remarkably persistent one. A more disturbing possibility is that the alignment is real and our understanding of the universe is incomplete. Perhaps the universe has a preferred axis. Perhaps there is a direction in space that is fundamentally different from others. This would violate the cosmological principle, the assumption that the universe is homogeneous and isotropic on large scales. This principle underlies all of modern cosmology. If it is wrong, our models of how the universe evolved might be wrong. Some theoretical physicists have proposed exotic explanations. Perhaps our universe is rotating. This rotation would create a preferred axis, but measurements show no evidence of universal rotation. Perhaps the universe has a shape that creates this alignment, but we do not know what that shape would be. The most radical hypothesis suggests the alignment is evidence of something beyond our universe. Perhaps we live inside a larger structure that has its own orientation. Perhaps our universe is embedded in a multiverse with preferred directions. These ideas remain highly speculative. Most scientists believe a more conventional explanation will eventually emerge. But 20 years after discovery, the axis of evil remains unexplained. You live in a universe that appears to know where you are. The largest structures in the cosmos align with your solar system. Either this is the most extraordinary coincidence ever observed, or something is deeply wrong with our understanding of reality. And while the cosmos appears to point at us, it also emits mysterious radiation that might reveal its hidden components. Strange X-rays are leaking from galaxy clusters. In 2014, scientists detected an unexplained emission line at 3.5 kiloelectron volts. This signal appeared in observations of galaxy clusters, regions where dark matter concentrates. The signal did not match any known atomic transition. No ordinary matter produces X-rays at precisely this energy. This is confirmed by observations from multiple telescopes, including XMM, Newton, and Chandra. The signal is real. It comes from regions dominated by dark matter. Could this be the first direct detection of dark matter particles? The signal appears strongest where dark matter is most concentrated. This correlation suggests a connection. Perhaps dark matter particles occasionally decay or interact in ways that produce X-rays. If so, this emission line could be the signature scientists have searched for. Think of trying to find someone in total darkness. You cannot see them, but you hear their breathing. The sound reveals their presence. The X-ray emission might be dark matter's breathing, the first evidence of its true nature. The leading candidate particle is called a sterile neutrino. This theoretical particle interacts very weakly with ordinary matter. It could decay slowly, producing X-rays at the observed energy. If dark matter consists of sterile neutrinos, the decay should create this exact signal. But the detection remains controversial. Other scientists argue the signal comes from known atomic transitions that were previously unaccounted for. Perhaps hot gas in galaxy clusters contains ions in excited states that emit at 3.5 kiloelectron volts. The correlation with dark matter would be coincidental. Recent observations have added complexity. Some galaxy clusters show the signal, others do not. If the emission comes from dark matter, it should appear wherever dark matter concentrates. The inconsistency raises doubts. Another possibility is that multiple sources contribute X-rays at this energy. Perhaps some signal comes from dark matter decay and some from ordinary matter. Separating these contributions requires more sensitive observations. The signal is weak. Detecting it requires long exposure times and careful analysis. Systematic errors could create false signals. Statistical fluctuations could mimic real emissions. distinguishing genuine signals from noise remains challenging. If confirmed as dark matter decay, this detection would revolutionize physics. It would identify dark matter's nature. It would prove that dark matter is not just gravitational scaffolding, but actual particles that can be detected and studied. Scientists are planning new observations with more sensitive X-ray telescopes. They are analyzing archival data from previous missions to search for additional examples of the signal. They are developing new theoretical models to predict what dark matter particles should do. The next generation of X-ray observatories will have the sensitivity to definitively confirm or refute the dark matter interpretation. Within the next decade, we might know whether we have detected dark matter or simply found a new emission line from ordinary matter. You are surrounded by dark matter right now. It passes through your body every second. If it is decaying, it is producing X-rays as it does so. These X-rays are too weak and too infrequent to harm you, but they might be the first whisper from the invisible universe. While mysterious X-rays hint at dark matter's nature, we might already be living inside one of the largest structures we have tried to find. Our galaxy might sit inside a void 2 billion light-years wide. Scientists measuring the expansion rate of the universe discovered an anomaly. Observations of nearby space suggest the universe expands faster than observations of distant space indicate. This discrepancy has puzzled cosmologists for years. One explanation is disturbing. Perhaps we live inside a massive underdense region. The KBC void, named after its discoverers, would be one of the largest structures in the cosmos. This is based on measurements of galaxy distributions around us. Out to about 1 billion light-years, the density of galaxies appears lower than average. We might sit near the center of an enormous bubble with fewer galaxies than the universe normally contains. Think of living in a valley surrounded by mountains. Your view of the horizon is distorted by the nearby terrain. You might misjudge distances because your perspective is unusual. The KBC void would create a similar problem, but on cosmic scales. If we live inside a void, measurements of the universe's expansion rate would be biased. Light from distant supernovas would travel through regions of different density. This affects how we interpret their brightness and distance. Our calculations of dark energy might be wrong. The implications are profound. Dark energy was discovered by measuring the expansion rate using distant supernovas. If those measurements are contaminated by our location inside a void, the evidence for dark energy weakens. Perhaps the accelerating expansion is partly an artifact of where we happen to sit. But this creates new problems. If we are inside a void, why? Voids are common, but sitting near the center of such a massive one seems unlikely. The probability is low, but not impossible. Perhaps we simply got unlucky. Other scientists dispute the existence of the KBC void. They argue the evidence is not conclusive. Galaxy surveys show underdensities, but these might be part of normal cosmic structure rather than a distinct void. The measurements could be affected by selection biases in how we count galaxies. Recent observations have tried to test the void hypothesis. If we live inside a massive underdense region, light from the cosmic microwave background should show specific patterns. The integrated Sachs-Wolf effect would create temperature variations as light crosses the void. So far, these predictions have not been clearly confirmed. Another test involves measuring galaxy motions. If we sit inside a void, galaxies near the edges should move outward faster than those near the center. This creates a specific velocity pattern. Some observations support this, others do not. The debate continues. More precise measurements of galaxy distributions are needed. Deeper surveys must map more of the universe to determine if the underdensity is real and how far it extends. If confirmed, the KBC void would rank among the largest structures ever discovered. It would challenge our understanding of how structures form. Voids this large should be rare. Finding ourselves inside one would be an extraordinary coincidence. Unless voids are more common than we think. Unless the universe is filled with bubbles and we happen to live in one. Unless our location is not special at all. just a normal position inside a foamy cosmos. But whether we live in a void or not, strange things have happened to planets in our cosmic neighborhood. 500 million years ago, Venus destroyed its entire surface. The planet is covered with volcanic plains showing no craters older than 800 million years. This is confirmed by radar mapping from orbiting spacecraft. Something erased all previous features. The entire crust was replaced. Scientists call this global resurfacing. Every older crater was obliterated. The planet essentially vomited on itself, covering everything with fresh lava. Venus is similar in size to Earth. Both worlds formed from the same material in the same region of the early solar system. They should have evolved similarly. Instead, Venus became a hellscape with temperatures hot enough to melt lead and atmospheric pressure 90 times that of Earth. Think of finding a house where every surface has been recently repainted. Not just the walls, but the floor, ceiling, furniture, everything. The house is the same structure, but none of the original surfaces remain visible. Venus is similar. The planet exists, but its original surface is gone. What could cause global resurfacing? The leading theory suggests that Venus's crust grew too thick. Heat from the planet's interior could not escape efficiently. The temperature below the crust increased. Pressure built over millions of years. Eventually, something gave way. The crust cracked on a planetary scale. Magma flooded through the fractures. Volcanic eruptions occurred across the entire surface simultaneously. The planet was buried under oceans of lava. This is called catastrophic resurfacing. It would have been the most violent geological event in the solar system's history. For millions of years, Venus would have glowed like a coal in the darkness. But Venus has no plate tectonics. Earth's surface constantly renews itself as plates sink into the mantle and new crust forms at spreading centers. This releases heat continuously. Venus lacks this mechanism. Heat builds until the entire system fails. Some scientists propose Venus experiences these resurfacing events regularly on timescales of hundreds of millions of years. The planet might go through cycles. Heat builds, pressure increases, the crust fails. Resurfacing occurs. Then the cycle begins again. If this theory is correct, Venus might be approaching another resurfacing event. Or it might have just completed one 500 million years ago and now sits dormant for the next few 100 million years. Nobody knows for certain. Venus is difficult to study. Its thick atmosphere blocks optical observation of the surface. Landers sent to Venus survive only minutes before being crushed and melted. Most of our knowledge comes from orbital radar mapping. Recent observations suggest Venus might be geologically active now. Some regions show changes between observations taken years apart. If true, Venus might not be dormant. Volcanism might continue, just not at the catastrophic scale of global resurfacing. The conditions on Venus are so extreme that studying its geology teaches us about planetary limits. How hot can a planet become before its surface melts? How thick can a crust grow before it fails? What happens when a planet loses its ability to cool itself efficiently? Venus also serves as a warning. Earth could become Venus-like if runaway greenhouse effects occur. Understanding what happened to Venus helps us understand what must be avoided on Earth. While Venus buried itself in lava, another planet suffered a different fate. Something tore away most of its outer layers. Mercury is missing most of itself. The planet's metallic core represents roughly 60% of its volume. Earth's core is only 10% by comparison. Mercury should have a thick rocky mantle like other rocky planets. Instead, most of that mantle is gone. This is confirmed by measurements of Mercury's density and gravity field. The planet is too dense for its size. It contains too much metal relative to rock. Something removed the outer layers. Scientists have proposed two main theories. Either Mercury's crust was stripped away by a massive collision, or it was boiled off by radiation from the nearby star. The collision hypothesis suggests a Mars-sized object hit Mercury billions of years ago. The impact would have been catastrophic. Rock from the outer layers would have been blasted into space. Most of this material would have fallen into the star or been ejected from the solar system. Mercury would have been left as a metallic core with only a thin shell of rock remaining. Think of peeling an orange and throwing away most of the fruit, leaving only the core. Mercury might be the core of a once larger planet. But the collision theory has problems. The impact would have heated Mercury's surface to extreme temperatures. Evidence suggests Mercury's surface has not been completely melted. Some surface features appear ancient. They should not have survived such a violent collision. The alternative explanation is equally disturbing. Young stars emit intense radiation. In its early years, our star might have been much more active. Powerful stellar winds and radiation could have heated Mercury's surface until rock vaporized. Over millions of years, the outer layers might have boiled away into space. This is called preferential vaporization. Lighter elements and compounds vaporize more easily than heavy metals. If radiation stripped away Mercury's crust, it would remove rock while leaving the metallic core mostly intact. Recent observations from the Messenger spacecraft that orbited Mercury found evidence supporting both theories. The surface shows ancient impact scars, suggesting violent collisions. But chemical analysis reveals unusual compositions consistent with high-temperature processing. Perhaps both events occurred. A collision stripped away some of the crust. Then radiation from the star vaporized much of what remained. Mercury might be a twice-wounded world, first hit by an impact and then slowly cooked by its star. Mercury's proximity to the star makes it difficult to study. Only 2 spacecraft have ever visited. Messenger orbited from 2011 to 2015 before deliberately crashing into the surface. Bepi Colombo is currently en route and will arrive in 2025. These missions reveal a world of extremes. Surface temperatures range from 800 degrees Fahrenheit in sunlight to negative 290 degrees in shadow. The planet has no atmosphere to distribute heat. Day side and night side exist in completely different thermal regimes. Despite being so close to the star, Mercury has ice in permanently shadowed craters near its poles. These regions never receive direct sunlight. They are cold traps where water delivered by comets has accumulated over billions of years. Mercury represents what can happen to a planet too close to its star. It is a warning and a mystery. It shows that planetary evolution is violent and unpredictable. But all the violence and strangeness in the solar system pales compared to the deepest mystery of all. How did any of this begin? Nobody knows how life began. 4 billion years ago, Earth was covered in oceans, filled with dissolved minerals and organic molecules. Lightning struck constantly. Meteorites bombarded the surface. Energy flowed through the system. Somewhere in this chaos, molecules started replicating themselves. This is confirmed by the fossil record and chemical analysis of ancient rocks. Life appeared relatively quickly after Earth's surface cooled. The transition from chemistry to biology happened within a few 100 million years. But how? How do dead molecules suddenly start living? The simplest living cell is extraordinarily complex. It contains thousands of different molecules working together in coordinated systems. DNA stores information. RNA transcribes that information. Proteins perform functions based on those instructions. Membranes separate the cell from its environment. Metabolism extracts energy from the surroundings. All these components must work together. DNA is useless without proteins to read it. Proteins cannot be made without DNA's instructions. The system is interdependent. Every part requires other parts to function. Think of finding a fully assembled car in the middle of an empty desert. The car contains thousands of parts precisely fitted together. Nobody built it. It just appeared. This seems impossible. Yet life's origin requires something similar. Complex molecular machinery assembled itself from random chemistry. Scientists have recreated some steps in laboratory experiments. The Miller-Urey experiment showed that amino acids, the building blocks of proteins, form naturally when simple gases are exposed to electricity. Other experiments have produced RNA molecules that can replicate themselves. These are important clues, but a huge gap remains between producing a few organic molecules and creating something alive. The leap from chemistry to self-replicating systems is enormous. Nobody has created life from scratch in a laboratory. One hypothesis is that life began in hydrothermal vents deep in oceans. These underwater volcanoes release hot, mineral-rich water. The temperature gradients and chemical environments near vents might provide energy and conditions favorable for forming complex molecules. Another idea is that life began in shallow pools that dried and refilled repeatedly. The wet-dry cycles could concentrate molecules and promote polymerization. Clay minerals in these pools might serve as templates helping molecules organize. Some scientists propose that life did not begin on Earth. Instead, microbial life might have originated elsewhere and been delivered by meteorites. This is called panspermia. But this just moves the question: how did life begin wherever it started? A deeper mystery is why life uses the molecules it does. DNA and RNA are extremely complex molecules. Could life have started with simpler genetic materials? If so, why did everything switch to DNA and RNA? Or were these molecules uniquely suited for information storage from the beginning? Life also uses only 20 amino acids to build proteins, even though hundreds of amino acids exist. Why these 20? Is there something special about them? Or is this simply the set that happened to be used first? Every living thing on Earth shares the same basic biochemistry. This suggests life arose only once. If life started multiple times with different chemistries, we should see organisms with fundamentally different biochemical systems. We do not. You are made of atoms that were once scattered across Earth's oceans. Somehow, those atoms organized themselves into molecules. Those molecules began replicating. They evolved over billions of years into every living thing, including you. But before any of this could happen, the universe itself had to begin. And that raises the most disturbing question of all. 13.8 billion years ago, everything began. Space, time, matter, and energy all emerged from an initial state of infinite density and temperature. The universe expanded from a single point. This is the Big Bang. It is confirmed by multiple independent observations, including the cosmic microwave background, the abundance of light elements, and the expansion of space. But what happened before that? The question might not make sense. Time itself began with the Big Bang. The word before requires time to exist. If time started at the Big Bang, there was no before. Asking what came before the Big Bang is like asking what lies north of the North Pole. The question contains a logical flaw. Yet the idea of something emerging from nothing is deeply troubling. Every human experience involves cause and effect. Everything has an origin. The universe itself seems to violate this rule by springing into existence spontaneously. Think of turning on a light. The light did not exist before you flipped the switch. But the switch existed. The wiring existed. The power plant existed. Causes led to the effect. The universe has no such causes. It is effect without cause. Some physicists propose that the universe emerged from quantum fluctuations. At the quantum level, particles appear and disappear spontaneously. Virtual particles pop into existence for brief moments before vanishing. These are not violations of physics. They are allowed by quantum mechanics within certain constraints. Perhaps the entire universe is a quantum fluctuation that happened to persist. Perhaps something about the initial conditions prevented it from vanishing. This would explain existence without requiring anything to exist beforehand. Other theories suggest the Big Bang was not the beginning. Instead, it might have been a transition. Perhaps the universe existed in a different form before expanding. Perhaps it was contracting, reached a minimum size, and then bounced back into expansion. This is called the Big Bounce. If true, the Big Bounce suggests an eternal cycle. The universe expands, eventually stops, contracts back down, bounces, and expands again. This cycle might repeat forever. There would be no ultimate beginning, just an infinite series of bounces stretching into the past and future. A related idea is that our universe is one bubble in an eternally inflating multiverse. Quantum fluctuations in a high-energy vacuum state cause new universes to bud off constantly. Our Big Bang was just one bubble forming in this larger structure. The multiverse has no beginning or end. These theories are difficult or impossible to test. Events before the Big Bang, if they occurred, left no observable traces. The extreme conditions during the first moments of expansion erased any information about prior states. We are cut off from whatever came before. Stephen Hawking argued that asking what came before the Big Bang is meaningless. Time has a boundary at the Big Bang, just as space has a boundary at a black hole's singularity. There is no before because time itself is bounded. You exist because the universe began. But why did it begin? Why does anything exist rather than nothing? Why are there laws of physics? Why do these particular laws apply? These are the deepest questions. They might have no answers. Reality might simply be an unexplained fact. Yet even accepting that the universe exists, we still do not know its ultimate nature. We do not know what shape the universe is. When scientists measure the geometry of space, they find it is flat to within measurement precision. Parallel lines remain parallel. The angles of triangles sum to 180 degrees. Space follows Euclidean geometry on the largest scales we can observe. This is confirmed by precise measurements of the cosmic microwave background. The patterns of temperature variations reveal the geometry of the universe. The data shows flatness, but flat does not necessarily mean infinite. A flat sheet of paper extended forever would be infinite, but a flat sheet of paper rolled into a cylinder is finite yet has no edge. Space could be flat, but still finite if it wraps around on itself in higher dimensions. Think of a video game character walking across a screen. When the character exits on the right side, it reappears on the left. The screen is flat, but finite. It wraps around. The universe might work similarly, but in 3 dimensions. Scientists have searched for evidence of such wrapping. If space curves back on itself, we might see multiple images of the same galaxy in different directions. Light traveling around the universe in different paths could reach us from multiple angles. So far, no such duplicate images have been found. The observable universe has a boundary. This is not an edge in space, but a horizon in time. Light from beyond approximately 93 billion light-years has not had time to reach us. We cannot see beyond this distance because the universe has only existed for 13.8 billion years. But what lies beyond the observable universe? If space is infinite, it continues forever in all directions. Galaxies and structures extend beyond our sight, forever. If space is finite, it eventually curves back on itself. Traveling far enough in one direction would bring you back to your starting point. Some theories propose the universe is dodecahedral, shaped like a 12-sided die where opposite faces connect. Others suggest it might be toroidal, shaped like a donut. These exotic topologies would create specific patterns in the cosmic microwave background. None have been detected. The flatness itself is puzzling. For the universe to be precisely flat today, it must have been incredibly close to flat in the early universe. Any deviation from flatness grows over time. If the early universe had been even slightly curved, it would be dramatically curved now, yet it remains flat. This is called the flatness problem. The solution proposed by most cosmologists is cosmic inflation. During the first fraction of a second, the universe expanded exponentially. This expansion stretched any curvature flat, like inflating a balloon until its surface appears flat locally. But inflation raises new questions. What caused inflation? What ended it? Why did it expand space by the exact amount needed to produce the flatness we observe? Recent measurements have tried to detect subtle curvature. If space has even tiny curvature, it should affect the cosmic microwave background in measurable ways. So far, No curvature has been detected. Space appears flat to within less than 1% margin of error. You exist inside a universe of unknown shape. It might extend infinitely in all directions, or it might curve back on itself in ways you cannot visualize. The geometry of reality itself remains a mystery. And if one universe can exist, why not many? Our universe might be one of infinite universes. This is not science fiction. Multiple serious scientific theories predict that other universes exist beyond ours. These theories arise naturally from physics, not speculation. They are consequences of trying to explain what we observe. The first type of multiverse comes from cosmic inflation. If inflation occurred in our universe, it might be occurring elsewhere constantly. Quantum fluctuations in the inflating vacuum create bubble universes. Each bubble is a separate universe with its own space, time, and physical laws. Our Big Bang would be one bubble forming in an eternally inflating multiverse. New bubbles form constantly. Each becomes a universe like ours, but separate and unreachable. The space between bubbles continues inflating faster than light, preventing communication. The second type comes from quantum mechanics. The equations of quantum mechanics describe all possible outcomes of every event. One interpretation says all outcomes actually happen. When a particle decays, it might decay left or right. Both occur, but in separate branches of reality. This is the many worlds interpretation. Every time a quantum event has multiple outcomes, the universe splits. Each outcome occurs in its own universe. The number of universes increases exponentially with every quantum event. Think of every decision you ever made. In the many worlds interpretation, you made every possible choice. Each version of you exists in a separate universe, experiencing the consequences of different decisions. An infinite number of yous exist. The third type comes from the mathematics of string theory. The equations allow for many different configurations of extra dimensions. Each configuration produces different physical laws. If all possible configurations exist somewhere, there are perhaps 10 to the 500th power different universes, each with different physics. In some of these universes, electrons have different masses. In others, gravity is stronger or weaker. Most would be hostile to life. Matter might not form stable atoms. Stars might not exist. Only a tiny fraction would have laws permitting complexity. This might explain why our universe seems fine-tuned for life. It is not special. It is simply one of countless universes. We observe this one because it is the kind where observers can exist. This is called the anthropic principle. But the multiverse concept is controversial. Many scientists argue it is not science because it cannot be tested. If other universes are unreachable, how can we prove they exist? The theory might be untestable and unfalsifiable. Others respond that the multiverse is a prediction, not a hypothesis. We do not propose it to explain observations. It emerges naturally from theories designed to explain other phenomena. If inflation is correct, the multiverse follows. If quantum mechanics is complete, many worlds follows. Some claim evidence for the multiverse might exist. If another universe collided with ours before inflation separated them, it might leave an imprint in the cosmic microwave background. Scientists have searched for such collision marks. None have been confirmed. The multiverse remains theoretical. But if real, it means everything that can happen does happen somewhere. Every possible history plays out. Every version of reality exists. You are one consciousness in one universe, experiencing one path through infinite possibilities. Other versions of you make different choices, live different lives, ask different questions, and none of them, in any universe, can fully explain why anything exists at all.